Windows ME was pretty bad, but this one is even worse. All right, let's see. So class.
Yes.
All right, thank you guys all for coming here and paying attention. Now, I know no one is working on other classwork right now at this current moment in time because you already forget what we're doing while we're talking about it and doing it. So follow along carefully because it's going to be important. Now, infinite limits, limits at infinity, and asymptotes. Now, definition, help me out. What is a limit? For it to be a limit,
Both sides have to approach the
same number, right? Both sides have to approach the same number. Now, can I have a one-sided limit?
No. Yes.
Yes. I can have a limit from one side. So that's with the pluses or minuses. Okay? So that's important. So let's go ahead and now take a look at what we got here. So investigate infinite limits. As x approaches 0, the value of 1 over x squared increases without bond. Okay, since the value of 1 over x squared is not approaching a single number, limit of f of x approaches 0 does not exist. However, since the numbers are increasing without bond, we describe the behavior of the function near 0 by writing it as it's going to infinity. Now, serious question. It just said it's not approaching a single number. Is infinity a number? No. Infinity is not a number. Infinity is an idea. We cannot put infinity on a number line. That's the definition. If you cannot put it on a number line, it is an idea. Okay? There's a joke. Chuck Norris counted to infinity twice. Okay, anyway, but still. So, this limit is not exists, but it has an infinite limit as approaches 0. I'm going to pull up my calculator. So now, let's do a calculator check right now. Let's see who all remembered to bring your calculator here today. Let's check on calculators. Oh. Mm-hmm. Mm-hmm. Is that one yours? Uh-oh. It's almost like I have a whole bunch of them that I already know about. I normally only have one calculator over here, so me having a whole bunch of calculators over here, I already know that there's a problem. All right, so there we go. So I am entering it in my graph, 1 over x squared, because we're going to look to see the behavior of this. Hey, Kissnet, where's your calculator? Huh? Oh, you left it at home. Are you sure? Do you know what number your calculator is, Kissnet? 50. 50? Let's see. Is it 50? It is 50. Let's see what we have over here. 69. Oh, what is this? Oh, whose calculator is this? New calculator, who this? Stop losing it or I'm going to start charging you. All right, there we go. Hit enter. Now we're looking at the behavior. As the limit approaches 0. So going from the left-hand side, it is approaching, it's going up to infinity. There is an asymptote at 0. X equals 0 here. From the right-hand side, it is approaching, same thing, infinity. It's both going up to infinity. So I could say that the limit goes to a positive infinity on this one. Okay? Because same rules for infinity apply. So if they both go to positive infinity, I could say positive infinity. If they go to different sides, like this, if you guys are looking at my hands, I'm doing some crip walk up here, so I'm like throwing up gang signs. So yes, up and down, it's not going to be unless you're actually looking at it one-sided. There we go. Investigate an infinite limit. Now, ln x. This is one of those things that you should probably try to remember what it looks like. Try to remember what it looks like. So we use this so often that this is one that you should try to remember. So it is ln x, right? Ln, it's right there. Blue, there, ln x. Okay. So you guys can use the little mouse pad to zoom in like that. You can grab an axis and just click on it and pull it over. The trackpad on there. Okay, here it is. If you notice, right here, this is going to be 1. Because we know that ln of 1 is going to give me 0. That's one you should always know. One of those things. You're going to see it so often. ln 1 is what? 0. So I know you're not doing this like I already asked, because you're paying 100% attention right here. So that means that as it approaches 0, it gets closer and closer to 0, it's going down to what? Negative infinity, because it does not exist at ln 0. ln 0 does not exist. So I have an asymptote right there, and then from here, at 1, it crosses over into the positive numbers. Did it not work? Okay. So let's go back to the question. Investigate it. Now, this is a one-sided limit. This is a one-sided limit from the right-hand side. So from the right-hand side, this is saying ln x approaches 0 from the right. So we could say that that one, it went down to negative infinity. So I can see it goes down to negative infinity there. It goes on forever. Questions? Do you guys do a lot of graphing of ln's and logs previously? And exponential? I almost heard what you said. Not really? Kind of? Okay. So these are ones that you're going to see so often, and that's why I'm saying you should be able to recognize what it is. All right, so that one's there. Go back to this. Next one. Investigate a limit, an infinite limit. Investigate this one right here. Now, one-sided limits. One-sided limits. Is there going to be a something, an undefined at 3? Can I plug in 3 directly? I can't plug in 3 directly, right? Because if I plug in 3, it's going to get 0 in the denominator. But there was something that we could do previously, sometimes. Can I remove that discontinuity? Let me give you an example of a removal discontinuity. Wait, let me change this one to make it. There we go. Can I plug in 3 into this?
No.
Because why? I get 0 in the denominator. A removable discontinuity, that's going to give me my whole. So can I factor the top? Yeah. If I factor the top, I get x plus 3, x minus 3, and right there, my x minus 3's cancel. That is a removable. This gives me a whole. At right there. Do I have that in my problem over here, though? I don't. I can't factor the numerator to try to remove it to cancel it out. So what I can do is, it says from the right-hand side. So give me a number on the number line, really close to 3, but on the right-hand side. Closer to 3. 3.1. That's a good one. I like that one because I could do the math easily. And I'll show you why. So if I do 3.1, so this is going to give me 6.2 plus 1 over 0.1, right? And how do I get rid of that 0.1? You guys might have had this back in elementary school. You might have actually done it a long time ago and just completely forgot. Watch this. Basically multiply both sides by 10. So that's going to give you 72 over 1. So what do you think this is going to? That's a really large number, but what type of number is that? It's a what? Anyone? I can't hear, so I need you guys to speak up, please. It's whole, okay. It doesn't have to be whole, because I just plugged in 3.1, which is going to give me like that.
It's a finite number. Like it exists.
It exists, right? It exists. Okay, but as we get closer and closer, okay, how about this? Is it positive or negative? Positive. So if I do this again, but instead of doing 3.1, let's go 3.01. So that's going to be 7.02. How do I clean that up? Huh? Not bad. I had to go make my own copies this morning.
Oh.
It was horrible. I didn't know how to actually interact with people. It was weird.
There was a lot of people in there?
No.
Oh, okay.
Yeah, it's just one of those things.
Got it. So you're good.
Uh-huh. Yeah. Thank you. All right, so what do you think I should do there? Multiply by 100. Move over twice. 1, 2. So that's going to give me 702 over 1. So as I'm getting closer and closer to the number 3, infinity. What type of infinity? Positive infinity. Because if I'm dealing with things in infinity, it's either a positive or negative. I just need to know which direction it's going. I know that this is going to be some type of asymptote. I know it's approaching it, and it's either going to be going up or going down. So by doing this, by just plugging in these numbers really close, I can get a sense, be like, okay, is this going up to positive infinity or negative infinity? Because at 3, exactly, it's going to be undefined. So this, for part A, I can say that's going to go up to positive infinity. All right. Yes.
You can't factor the top, and if you substitute with where it's approaching, it'll always be an asymptote, right?
If I can't factor it
Yeah.
and it's going to be undefined,
So it's an
you
asymptote
should have an asymptote.
always.
You should. Like at this current moment in time, I'm saying like 90%. I can't think of anything off the top of my head right now that you're going to come across that it's not. Because you might have like some weird radical something. Okay, so right now that's all we're dealing with. What about this one? So I know that from my graph, ln x at the number 1 is going to give me what? This would have had you guys actually say, hey, that's going to be 0. From my graph, ln 1 is 0. So remember the image of the graph. To the left side of 1, where was that graph located at? It's in the negative. Very good. That's what I'm looking for. It's going to be a negative, isn't it? So the left side of the graph on this part right here, as it's approaching, that right there is going to be a negative value, right? Okay, so whatever it is, it's going to be a negative. But then over here, x squared, what is, can I do 1 squared? Yes. Okay, and so that's going to be 1, isn't it? So it would basically be 1 over, as I'm doing this, it's going to be some negative value. So it's going to come up really small. So it's going to be 0.001, right? Getting really close to it. And this would be the same thing. If I square it, it's going to be positive 0.001 squared. The top is always going to be positive. Why is the top always going to be positive? I'm squaring it, right? So whatever number I plug in, it has to be squared. So if I plug in a negative number and I square it, it's going to give me a positive no matter what. But my bottom is going to give me, the left side is going to be a negative value. So right here, this is going to go to where? Positive or negative infinity? Why? Why? No, look at what we have right here. This is going to give me what type of number? That's going to give me a positive number, and the bottom is going to always give me a negative number. So a positive divided by a negative should give me a negative. So that's going to give me my direction. So am I saying we're solving everything? No. We're plugging something in to see which direction it's going, because I'm looking and it is going that way. So this one was control divide x squared over ln of x. There you go. X. There, 1x. There you go. Now, which side of this am I talking about? The left side. So the left side right here is going down to a negative infinity. Why is it right here that the right side is going up to positive infinity? Look at that ln. Remember the image or the graph of ln. ln at 1 is going to give me 0. But to the right of 1, it's above the graph, isn't it? It's above the axis. So those are going to give me all positive numbers above the axis right there. So no matter what the bottom, I'm going to have positive for everything to the right of 1. That's why it looks so wonky like this. Like that right there. So we don't need to graph this every single time. We can start plugging in values that are super close to be able to test this. Because a lot of times you're not going to have access to a calculator on some of these. So all you have to do is start plugging in to see if this is going, if it is a asymptote like we're coming up with here, I need to know the direction of that asymptote. Is it going to positive or is it going to negative? Does that make sense? Yeah? Blade, good? Are we good? Okay. Dory? Okay. Find any vertical asymptotes of this graph. Now, vertical asymptotes are going to be where? X what? What about the x-axis? Yes, they are. Okay. So that has to do with something in my x, right? Can I plug in an x right there? If it's an asymptote, what happens when I plug in that value? It is undefined. Very good. If I'm looking for an asymptote, I want it to be undefined. My x value needs to be undefined. That's what's going to give me this. So look at that carefully, and I'm going to factor it. So I'm going to get f of x is equal to x over x minus 3, like that. Any place in which that this is going to be, x cannot equal what? X cannot equal 3. Is there a removable? Is there a removable here? There is not. Because a removable, which is going to give me factoring the numerator and denominator. So canceling out. I'm not canceling anything out. That x right there, that one's stuck. And because it doesn't have a minus 3 attached to it, it's got to stay as is. So let's see what we have. Just to verify with my graph. Doc B. And we have control divide x over quantity of x minus 3 close square. There you go. Bam. Are we good? Questions, concerns, complaints, conspiracy theories? No? We good? Okay. All right, so I think that's the last one I was going to plan on for today, because we have these right here. These are just the properties talking about limits at infinity. Now, here's something really easy. What is 5 times infinity? It's infinity. Is infinity a number? No. Infinity is it's an idea. So 5 times infinity is still infinity. That's important. That's basically what this is actually talking about, this first one here. And then infinity divided by infinity? It should be 1. It should be 1. Okay? Depends on how it's doing. So before we actually start this next one right here, we're going to stop right here. We're going to pick it up tomorrow. You guys are going to work on your assignments. Okay? And like, share, and subscribe. Right? Buy stuff for the merch store.